Panasonic Narrow Pitch Connector series includes over 3,000 parts. The connectors and total service required by customers, including manufacturing through after-sales care, are available in various countries and regions through our supply system and sales network. Panasonic has released connectors suited to mobile equipment, which is getting smaller and boasting higher functionality. These connectors have a high reliable contact structure, Bellows type contact structure to provide high contact reliability against vibration or impact, V-notch to remove foreign particles and flux for enhancement of the contact reliability, nickel barrier to enhance the resistance to solder rise, porosity treatment to enhance the resistance to corrosion by gases, Standard tuning fork-type contacts are made by stamping a thin plate into the contact shape. Since the plate width is larger than the thickness, the contact flexibility becomes low, making the contacts more susceptible to a drop impact and causing solder cracks. Also, the plated surfaces are worn out easily because the cut ends rub against each other. Our Bellows-type contacts are made by stamping a thin plate at the terminal pitch and then bending it into the contact shape. The Bellows-type contacts have excellent contact reliability and resistance to solder joint removal because the plate width can be optimized according to the terminal pitch. The sufficient flexibility absorbs drop impacts, providing the ultra-miniature body with high strength to drop impact and high-level reliability required for mobile equipment. The smooth and rolled contact surfaces prevent the gold-plated surfaces from wearing out, providing high resistance to corrosion due to ambient environmental conditions. The simple lock structure gives tactile feedback that ensures reliable insertion-removal operations. The globalization of equipment production is promoting the outsourcing of assembly processes, making it difficult to closely manage environmental conditions at production sites. We have developed our unique V-notch contact structure on the assumption that connectors can be mounted or assembled in a dusty environment. This new structure has remarkably enhanced the resistance to the entry of foreign particles. A V-shaped notch is made around the contact points of the header so that the contact positions will shift during connection of the header and socket. The previous rounded surface contact structure was changed to the two-point edge contact, increasing the contact pressure per unit area. In combination with a structure that shifts the contact positions during the connection process, the V-notch structure has achieved high resistance to entry of dust, dispersed flux, or other foreign particles of a level that cannot exist under actual environmental conditions of use. In addition, the double contact structure securely holds the header for further improvement of the contact reliability. The V-notch and double contact structures generate synergetic effects, allowing for significant enhancement of the contact reliability. As you can see, the contact resistance showed no significant change after the dust spray. The use of lead-free solder is promoted for environmental conservation purposes. Since the appearance of N2 reflow soldering machines and flux providing superior solder wettability, the prevention of solder rise has been a serious issue for ultra-miniature connectors. We have developed a nickel barrier structure, which is formed by exposing the nickel-plated layer having low solder wettability in the upper section of each terminal. The nickel barrier prevents solder from rising, allowing reliable solder fillet forming. The contact surfaces of connectors are gold-plated for protection from corrosion. The thickness of gold plating of electronic components is as thin as 0.1 to 0.2 micrometers to minimize the costs. In such thin layers, pinholes are generated. At the interface between the gold-plated and nickel-plated layers, a local cell is formed due to the potential difference. This local cell action is further accelerated by the presence of any electrolyte, such as salt or fresh water. When sulfur dioxide increases while the local cell action causes the nickel-plated layer to become susceptible to sulfurization, they are combined, depositing an insulating material and thereby causing corrosion. Porosity treatment is a technology used to cover the pinhole surfaces with a very thin film. Panasonic has developed its unique porosity treatment material consisting of a synthetic component and lubricating component. The material provides high contact reliability even under adverse environments. This porosity treatment technology enhances the resistance to corrosion by sulfur dioxide and the insertion removal durability, maintaining the high contact reliability.
Panasonic.